Hello friends. So today in this video we are gonna cover some problems based on the topic RN method. In the previous video we have completed the RN method in detail. We have talked about it and how to determine this method is gonna be used. So in this video we are just gonna use this method to solve questions. So this is gonna be the first video and we will have many of the videos in which I would solve many of the questions for you guys. So first of all we are going to solve this question. Now to solve this question, the first step that we are going to do is convert this question. Whatever it takes, you're just going to convert this question into this form, the form that we studied in previous lecture. So this is r is equal to 0 to n minus 1 f of r by n. You're just gonna convert this question into this form. If you are successful in doing this, then then the question is almost done and we are just going to write that in integration sign and we're going to solve that. So to convert into this form, first of all you just need to notice what we need to have in out of these terms. So first is limit n tending to infinity, which we already have. Now we need summation, and we already have many of the terms in summation. Now the reason why we cannot solve this question in any other method is we have a power of 4 over here. If we had power of 2 or power of 3, then we know the formula of summation of these natural numbers. But since we have a power of 4, there's no known method to there's no known formula to solve these type of questions. That's why the Rn method comes into the scene. Now to solve this, we actually need a 1 by n, which we can easily take out from n to the power 5, then the summation, and then function of r by n. So let me just convert this and you would be mesmerized to see that how easy these questions are. It's just to catch these type of questions. So we can actually have 1 to the power 4 plus 2 to the power 4 plus 3 to the power 4 till n to the power 4 upon n to the power 4. So I've just taken an n out of this. Now we need to convert this into summation. Now we know that many of the terms are in addition over here, so we just need to convert this into r by n, the summation of r by n. So what we are gonna need is we just need to divide this n by 4 among the terms. So what I'm saying is this. I just separated the n with many of the values and I have this in the end. Now limit n tending to infinity. Now I'm just gonna write these terms into the form of summation. So summation of r in the initial is 1, so we have r is equals to 1, and in the end it is end, so it's n in the end. And now we have r by n function. Now the function is r by n to the power 4. Here if you put the value of 1, then we get this term, value of 2 we get this term, so we get all the terms by putting the value of r into this. So we have actually converted this form. Now the function, which is f, is actually to the power 4, so the function is to the power 4. Now if we need to convert this into the definite integration sign, we have actually taught this to you in the previous video. You can actually do this by, let's put the limit at the end. I'm just gonna leave boxes over here, and now we have a 1 by n could be replaced by dx, the function r by n could be replaced by x, and the function remains the same, which is to the power 4. And now put r is equals to 1 in the function, so we have 1 by n, and 1 by n would be equal to 0 because n tending to infinity we have, so 0 over here. And when we have n, r is equals to n, then putting the values we have n is equal and the value is equals to 1, so we have 1 over here. Now solving this, integration of x to the power 4 is x to the power 5 upon 5, and we just need to put the values over here. So when we put 1, we have 1 by 5, and when we put 0, we have a 0 over here, so the answer is 1 by 5. See, this is the answer to such a big problem, but these problems always have answer in very short form. So this is the answer. Thanks for watching.